So, hi everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, July 19th, 2013. Today we're going to talk about balloonatics, a new moon for Neptune, the fact that an astronaut almost drowned, recreating the pale blue dot, gold from stars, terrible heat wave, new images of Comet Ison, and water trapped on red dwarfs. Joining me this week, a ragtag crew of space journalists. We've got Sonny Springman at the Arecibo Observatory.
Hello.
We've got Amy Shira Teitel from Vintage Space.
Hello.
We've got David Dickinson,
Hey.
a.k.a. the Astro Guys. We got Jason Major.
How's it going?
And last but not least, we've got Dr. Matthew Francis.
Greetings.
All right, so let's get cracking first. Now, Sandy can only stick around for about another 20 minutes, so we're going to start with the story that she wanted to talk about, which is balloonatics. And I will be honest, I had no idea what she was talking about. I spent the first 5 minutes or so just trying to digest this new information. So, Sandy, please explain it to me again, and now use small words.
Only small words.
Yes.
Well, I'm a small person, so that's okay. So we're going to be, later in this hangout, you all are going to be talking about Comet Ison, which is going to be making a nice pass through the inner solar system later this year on Thanksgiving, actually. It's going to make its closest pass to Earth. And we're going to be pointing every spacecraft we possibly can lay our hands on at it. Messenger is going to be looking at it. Hubble's been taking beautiful images of it. And there's a bunch of other, I think even SOHO, anything that can point at the sun is going to be looking at this thing. But also there's some risk. As this thing comes in through the inner solar system, it might break apart if there's a coronal mass ejection, if there's a large solar storm, this thing could lose its tail. It could become a total dud for reasons we don't even understand. So a number of scientists at the Applied Physics Lab at Johns Hopkins University are actually designing a balloon to carry a suite of instruments up into the upper atmosphere, not quite the space, for 22 hours. And they're only going to get 10 hours of science out of this. But this is kind of nuts. So I'm calling them balloonatics for that reason, and I really hope this term sticks.
Well, there's a lot of really interesting balloon science. Have you seen the Blast documentary?
I love the Blast documentary. And one of my friends is actually working on Blast Pole, which is a successor. It's really neat.
If anyone hasn't seen it, it's not only is it sort of great if you love space, but it's actually like one of the best done documentaries I think I've ever seen.
It's a balloon and Antarctica.
Yeah, hard times 12. But, there's a lot of science that gets done with balloons like this. The high altitude weather balloons. So this isn't.
And the reason we do this at high altitude is because we have all this water in our atmosphere, and that's really great. But it blocks a lot of very interesting stuff that you would see in the ultraviolet. And we also have this really nice ozone layer. So the more you can get above our atmosphere, you can see stuff that our atmosphere would otherwise block. So that's why we try to have telescopes in space. We have telescopes on planes. And we also have telescopes on balloons. So this telescope's only going to be about 30 inches across. It's not even going to be a meter. But they're going to get a lot of stuff out of it. And they're not just going to look at this comet, but they're also going to look at a couple of asteroids and other objects that have interesting UV characteristics. So it's kind of nuts that it's only going to be less than a year from the time that they decided that this comet was actually discovered in 2012, I think, and when they've decided they're going to launch this thing in the fall. So that's bold, as Gentry Lee would say.
Bold.
Bold. So yeah, this is going to enable us to get some really sweet photos of Comet Ison, aside from the new ones.
What I've always wondered, being a backyard astronomer, it's tough enough to point my own telescope. How do they point a telescope on a balloon?
That's I think they were probably using star trackers. I think they're probably using a lot of the technology that they would use on spacecraft. That's just my guess.
But to reorient the balloon when it's up there to keep it pointed in the right general direction, then have the telescope itself actually be able to point. That's crazy. And then what happens when the balloon pops?
Well, it doesn't pop so much as they let it back down, and then they chop off the payload, and they expect to recover it, but it might be a few days. So you have to design for that. So
because if you ever see those people who launch those weather balloons, and they always, they go up really high altitude, and then I know, like with those weather balloons, they just get bigger and bigger and bigger until they pop.
Yeah, The goal is not to get this thing to pop, because that would be bad. I mean, you can sort of design your payload for litho braking, as they say, litho like the lithosphere, and braking like aerobraking, except you expect it to crash. So you don't really want things to crash. There's a video going around right now on YouTube of them putting this thing together, and it looks kind of delicate. I just wouldn't want that to crash into the ground. So this is kind of bold and audacious, and I hope they're successful, and I hope they get some really sweet images of this thing and get some great science.
Now, we got a request from YouTube. Somebody wants you to show us the dish.
I can't show you the dish from here.
Oh,
you
well,
might be able to see the telescope. There, you can see the telescope.
Oh, yeah. There we go.
Coming out of the woods.
It's become almost tradition.
And Hugo Burnham says, I didn't know you sailed, Fraser Cain, but actually I think it's your icon.
It's my icon with the sailboat.
Yeah,
That's
I actually do have a
18.
sailboat, though, so I do actually sail.
Can I come visit you?
Anytime.
Yes.
Okay. What is next? So let's talk about the new moon for Neptune. Amish, your title?
Yeah, Neptune has a new moon. Well, not really, because it's had that moon for a while, technically, probably. But it's new to us, so that's kind of neat. So it was Mark Showalter at the SETI Institute who was looking at pictures of Neptune taken by Hubble between 2004 and 2009, and he found a little dot. So he tracked this dot in 150 images and was able to actually figure out that it's a moon, figure out that it's orbit, and confirm that it's a moon. So now we have this moon that I think is called something like S2004-N1 right now. It's probably going to be named for a sea nymph before long, because all of Neptune's moons are named for some kind of sea goddess or sea nymph, because the Astronomical Society, or the IAU, has to do everything has to have a theme. But it's kind of a neat discovery, not just because it's a new moon, but because I think it's kind of a neat reminder that we don't actually know very much about that we don't actually know very much about Neptune. I mean, we only found Neptune in 1846. And then its main moon, Triton, was found within 17 days, I think. Sorry. And then the moons came pretty slowly thereafter. I forget when the second moon was discovered.
I think it was Nurid, I think, back in the 1940s. I can't remember the exact year.
You want to tuck your phone out that door and put it in that closet behind you?
Airplane
it's my mom. She keeps calling back when I hang up on her. I think you're right. Yeah, it was in the mid 40s that someone found it, and then it wasn't until Voyager 2 got to Neptune in 1989 that we discovered 6 more moons, and all of a sudden the system was huge, and Neptune has all this crazy weather going on in its clouds, and it has
and the ring arcs too.
Yeah, that people thought that, or astronomers rather, thought that it was sort of half ring arcs, and it turns out that they're very fine rings, but they're complete rings. And then in 2005 we found 5 more moons and more Hubble data. So this keeps coming. And I think it's kind of interesting that we don't think about how little we know about Neptune, but there's a lot to know about Neptune, and Triton itself is pretty awesome.
Well, a lot of this stuff comes in waves, right? You get the situation where you've got, like, I know with the with the New Horizons, right? It's going to be showing up at Pluto, and you're going to have a new instrument that's really close, and it's going to be able to. I'm sure if we've already found, what are we up to? 5? 12, however many moons.
5 for Pluto.
Yeah, there's going to be more probably when you get that instrument. You get this stuff in waves. We discovered a bunch with Voyager. So this is going to be. I think we talked about this last week. We need another ice giant mission.
We do.
Yes.
I would love to see something that goes, and I don't know anything about orbital trajectories, but something should go from Uranus to Neptune and study the moons on the way, because, yeah, that'd be awesome.
When I was a kid, Neptune only had 2 known moons.
Yeah, exactly. I was actually thinking about posting on Twitter, like, how many moons do you think Neptune has? Because I think in my mind it's 5. I'm trying to remember, like, when I learned how many moons it had.
When I was in grade school, it was 2.
It was 2, yeah.
So not till Voyager 2 went by in the late 80s did it start, the numbers.
When I was a kid, Pluto was a planet.
I know.
Thank you.
That kind of dates me.
That's
Isn't
awesome.
that true for all of us, though?
Yeah. Okay, so let's move on, and let's talk about this actually quite scary spacewalk that just happened this week.
Yeah, there was a routine spacewalk Tuesday morning. This was the second of two routine spacewalks. So they had done one the week before. This was Luca Parmitano and Chris Cassidy. Luca Parmitano is an ESA astronaut, and Chris Cassidy is a NASA astronaut. And I'm watching these spacewalks kind of over on one monitor while I'm writing, and I'm kind of intermittently like turning it on and muting it as they're doing it. And then in the first hour or so when I turned it on, I noticed they were starting, Luca Parmitano was starting to have reports of water in his helmet. And they cut that spacewalk short. It was supposed to be a 6 to 7 hour spacewalk. They finished a few initial tasks, but ended up only being an hour and 32 minutes. They got him back inside, and it was a little tense there. It wasn't as bad as it sounded once they got him back in, but there was points where they couldn't actually communicate with him. They were telling him over the comm that it's like, if you can hear what I'm saying, squeeze my hand. And he wasn't actually communicating out of the helmet. And he said later it was kind of like being, like a goldfish trapped in a bowl as the water was coming in there. So it was a little bit of a scary situation. He mentioned that the water, it didn't taste like the water and that they use for drinking water. It tasted more, it had kind of a funny taste to it. So, but when I watched a little bit of the NASA press conference afterwards, unless they just found out recently, they're not sure what the leak was exactly, but he's okay. There's never been an astronaut lost on a spacewalk. You remember Commander Hetfield had a moment where he was getting tears in his eyes, he mentioned at one time, and you can't like wipe your eyes or anything when you're in a suit. So if you lose your vision, you have a big problem out there as well. There's a lot of things in a spacewalk that can turn a routine spacewalk into a hazard very quickly.
Water just kind of sticks to the surface of things, and that does funny stuff, huh?
And I wrote a while back, too, about micrometeoroid impacts. I didn't realize this till I read it in Quarterly Space Debris News that NASA puts out, that they have problems with spallation, little micrometeoroid impact craters on the handles and the rails that they have to grab that become sharp and can actually cut the gloves of their spacesuits as they're walking. They've identified and filmed these little areas where there's little micrometeoroid impact areas. That's another problem that they have to watch out for on spacewalks. It's these handles over time. The International Space Station's been out there a decade now. It's getting pitted from these little micrometeoroid impacts that could easily pose a razor-sharp hazard to their gloves as well.
I'm picturing that scene in, if you haven't seen it yet, Europa Report.
No, I haven't. No.
I haven't seen that either.
Yeah, it's actually very cool, very cool sci-fi film that has a lot more sci than fi.
Wow.
Until you get to the end and stuff. But there is that whole idea of a spacewalk gone bad because of a rip in the
Isn't there a Sandra Bullock?
Yeah. I just saw the preview for that. I was at Pacific Rim, which rocked. And they had a preview for that movie. What's it called?
Elysium?
No, not Elysium.
No,
Sandra Bullock.
Spacewalk
movie.
Yeah.
Someone in the chat, please help us out. Sunshine, Skyfall, no.
Something like Stranded, something very descriptive.
Yeah, it looked, but I looked from what I could see from the, from the preview, it actually looked pretty realistic, kind of terrifying actually.
Is it Gravity? Was it Gravity?
Gravity? That sounds right.
Oh yeah, Gravity. That's the one where the trailer blew up the International Space Station.
Yeah.
Isn't that it?
Yeah.
Yeah, that was terrifying.
Yes.
Yeah.
That's coming out this fall.
And especially
Terrifying.
as she's like sort of floating off into space and can't quite reach the last part, and just that's it. There's nothing you can do. No way to get back.
I haven't heard a time if they're gonna redo this spacewalk at what point they're gonna. I haven't heard if they're gonna reschedule this one or not. They're probably gonna find out what the problem was first. Yeah.
But I mean it's become so routine. I mean, it's funny. We don't even report on Universe Today anymore. Like when there's a spacewalk. Like unless something, we report on this one. But if there's nothing really that big, we won't really even report on it.
It made all the major networks in a hurry once there was a problem with it. It was on the Yahoo front page within maybe 20 minutes. So once there started to be a problem. So.
Okay, so it's time for our selfie. Well, not exactly. It's time shortly today for a picture. You're gonna leave, Sandy?
Well, I'm
Or
going
you
to
just
wave at Saturn, too.
You're going to wave at Saturn. Okay. And then you're going to leave. Right. So Cassini, today is the day that Cassini is going to be recreating the pale blue dot and take a picture of Earth. And Messenger's getting in on the action as well. They're going to take a picture of Earth, too, from that perspective. So, Jason, what's the math here? How's this going to work?
Well, Cassini is obviously around Saturn, and it's going to be pointing at Saturn in such a way that the Saturn is between it and the Sun. So Saturn will be in eclipse, and Cassini is going to take a whole series of images. I think there's going to be at least 30 different frames across, so a bunch of images across, down over another row, and eventually those will be put together in a big mosaic that'll be beautiful and gorgeous and amazing, like everything else Cassini does. But in that shot, way off in the distance, actually just down and I believe to the right of Saturn, there'll be a little speck, a little blue dot, and that'll be us, because looking back towards the Sun, we're in that scene. So this is something that we knew was going to happen. That was announced to the public over a month ago. So in effect, this is the first time that the population of the world is being told beforehand that they're going to have their photo taken from nearly 900 million miles away. So that's the whole idea behind the wave at Saturn. The movement behind that. So it's like at this point in time, you look up in the sky, smile and wave. In fact, director of imaging, Carolyn Porco, she has another side site called The Day the Earth Smiled. So that's the idea is like everybody just give a smile out to Saturn, out to Cassini, because your picture is going to be taken. So it's kind of one for the history books.
Carolyn Porco has done a great job of sort of organizing this. If you ever sort of see her or kind of have talked to her, she's a very serious woman, and I think she's done a really great job of kind of coordinating and reaching out to the public and getting people involved in the Cassini mission. I mean,
well, she was involved in the last time that obviously the last time Cassini took a picture or a mosaic like this, which was back in I believe it was September 2006, and she was involved in the Voyager was it Voyager 1? Original pale blue dot imaging that was in 1992, I want to say, and that was taken from beyond the orbit of Pluto. So as Voyager was heading out, so this is kind of her thing.
I know she's done just a textbook job of being a really cutting-edge scientist, and really sort of helping bring that data in, and then also making sure that data gets out to the people as quickly as possible so that they can work on it, and then thinks up really clever ideas to sort of help whenever you can sort of synchronize the sides. I think a lot of other people that are involved on missions could really take a lot of messages, a lot of read from her playbook, because she's done a fantastic, terrific job.
Sure thing. So the images that are coming, that Cassini will be taking, it's today at 5:27 p.m. Eastern time. So wherever you happen to be, there's you can convert from there. I don't have the universal time, but anyway, it's 5:27.
So it's 3:27 right now, right? In your 3:25.
Yes.
So in 2 hours.
Exactly 2 hours from now.
From right now.
So that's when Cassini will start taking the photos. Now that time, 5:27, is adjusting for light travel. So in reality, it takes about 80 minutes for photons to travel from Earth to Saturn for Cassini to take the picture of it. So Cassini won't actually be taking photos when that wave at Saturn time is. It'll be later. But in order for it to be captured at the same thing, you got to account for that time span. So that's where the 5:27 comes in. So when you wave up at the sky, and don't worry if you're actually facing Saturn or not. The whole planet is really going to be about a pixel in size, so you got to use your imagination in the final one. But anyway, when you're waving out there, it's those waving photons will be traveling, and Cassini will be ready to pick them up when it does start to take its photos.
Occupy the pixel.
Occupy the pixel.
Yep.
Now, what about Messenger, though?
Messenger, as it turns out, is in orbit around Mercury, is doing the same thing. It actually took a series of photos aimed our way this morning, and it's going to take some more photos tomorrow morning. Now, what MESSENGER is looking for, it's not making this grand sweeping mosaic of Mercury and eclipse or anything like that. MESSENGER is looking for any moons around Mercury. We've all been taught that Mercury has no moons, like Venus has no moons, but kind of like Neptune, there could be moons around there that we just haven't found yet, because it's kind of a difficult spot to find anything, just because of its proximity to the sun and all this other stuff. So MESSENGER, having been orbiting Mercury since 2011, has occasionally looked out around the area around Mercury to see if there's any moons out there. So as it does this, it actually did 3 series of photos this morning, and it'll do 3 series of photos tomorrow morning. Earth will be captured in those photos as well. So we're kind of having, we're photobombing these space exploration missions on both sides of the solar system, I guess you could say. So it's kind of interesting. We're gonna see all of these perspectives on our planet. That's again, awesome. in MESSENGER's images, where the entire Earth-Moon system will be no more than a pixel in size, but it's still kind of exciting to get such a perspective on our planet from within our own solar system.
I love those. I love those pictures. I mean, when they take like the rovers and they take pictures of Earth from Mars, that's so cool.
It's this whole "you are here" concept, and what we look like from really not that far away. I mean, it's still within our own solar system, and we're just that little pale blue dot.
Now, Matthew, you had a story that you had proposed, and I realized that I didn't put on the list. And so I'm just going to let you talk now.
Okay. This is actually a bit of perspective on the history of our own solar system, a snapshot of a solar system to be another star that is about 80% the mass of our sun, so a little smaller. But the star system is similar enough to Earth, to the solar system, but it isn't there yet. It's what's called a protoplanetary disk. While I'm talking, I will bring up the image. But it's a.
Is this at the carbon monoxide snowline one?
Yes.
Okay. All right.
Okay. So here's the image. This is a sub-millimeter light image of this system taken with the ALMA telescope array in Chile, and the blue circle you can see in this picture is actually the same size as the orbit of Neptune, and the green is light emitted from the location of frozen carbon monoxide, which freezes at a lot colder temperature than water does. But here's the thing: is within that circle in our solar system, you have all the big planets. You've got the terrestrial planets, you've got the gas giant planets, you've got Uranus and Neptune. Outside that, you've only got little bitty stuff. The biggest thing out there is Eris, Pluto, that kind of stuff. The rest of it's little chunks of rock and ice, comets, that kind of stuff. So that's an important division in our solar system, and we're seeing that division in this distant star system. And here's the other cool thing about it, literally cool thing, but carbon monoxide is a catalyst for chemical reactions that lead to prebiotic molecules. Well, prebiotic, as you can probably guess, the name means it has to do with biology. Comets are chock full of stuff like amino acids and other molecules that are not the building blocks of life, but kind of the building blocks of the building blocks of life. And so there's a lot of hints that these molecules were brought to Earth and the inner solar system by comets at some point in the solar system's history. And so we are seeing where this carbon monoxide frost line is. Inside that ring, carbon monoxide is gaseous. Outside of it, it is solid. And so it's just a very interesting thing. We're seeing kind of a snapshot of what our solar system would have looked like when the sun was about 10 million years old, which in star terms is pretty young. humans, we think of 10 million years as being a long time, but it's actually not that. The star systems form pretty rapidly in cosmic terms. So this is a snapshot of that point in history, and it's really, really interesting.
What kind of star is that, Matthew?
It's called a T Tauri star. So it's technically it has not entered what's called the main sequence, which is the phase that our sun is in. So it's sort of a pre-star, but it's again it's going to be fairly sun-like when it's actually has ignited and become a normal-ish star.
And I was, here in our solar system, right? You got the situation with our snow line, but it's the water snow line, right? So you've got, Vesta, and you've got Dawn, and
right.
on opposite sides of the snow line. We've already looked at Vesta, which is on the inside of the snow line.
Right.
And it's a rocky world, craters. But next comes Ceres for Dawn, and it's going to have ice and snow and look like a moon of Saturn a bit.
Of Jupiter, yeah.
Yeah, so I think
so,
it's the same situation, right? But instead of it being water, it's carbon monoxide, and so just different.
Right.
Yeah.
And actually, that's another good point. Of course, in our solar system, you've got on the near side of the ice snow line, the water snow line, you've got the terrestrial worlds, the rocky worlds, and on the far side, you've got Jupiter. Okay. Well, obviously, there's something really big and important that happened on that. But of course, if you look at at how much of a difference that is, that's a lot closer to the star. Okay, it's a lot harder to find the snow line for water. So that's this took all the power of ALMA to find this carbon monoxide snow line. So we're going to have higher resolution still to see where the water snow line is. So I guess that's sort of the next step. Can we see that? Can we pinpoint it? And that would be a really cool thing too.
So we got a question here, and I actually wanted to fire this off to Amy. So this relates to Luca's spacewalk. Does anybody know what the procedure is for problematic suits? Is the suit returned to Earth in a later Soyuz resupply mission, or replaced, or inspected, or fixed? Do you know how they have dealt with this kind of thing historically?
No.
Nope. Okay.
Actually, that's a really bad answer. No, the sort of the most troubling spacewalk that comes to mind historically is Gene Cernan's spacewalk on Gemini 9, when they hadn't really figured out to put handles on the capsule yet, so they were just like groping around on this smooth thing, and he worked up such a sweat. I think there was like 2 liters of fluid in each boot just from sweat, but they didn't. It was a short mission. They didn't even take the suit off. He just came back to Earth, and he got onto the carrier deck and like dumped out water from his boot. I know historically the procedure, just since we were talking about the movie Gravity, if an astronaut were to spin off into space, procedure called for the commander to come back alone, or the remaining crew to come back alone. There were no provisions to rescue a stranded crew member.
Wow.
Little fun fact. There's I think it's in Deke Slayton's autobiography where he talks about bringing commanders of missions into his office and saying, okay, so we're going to go do a spacewalk, and if anything happens, you shut the hatch and you come home alone. And they all had to do it. Thankfully, nobody did, but that was procedure.
I think Alexei Leonov on his first spacewalk nearly had some overheating problems, he said.
Yeah. He also had the problem that his suit expanded when he got out into the vacuum, and then he couldn't fit into the airlock, so he had to bleed the oxygen out of his suit to deflate it, but not so much that he would die. So he's very, cautiously bleeding out air. Yeah.
That amazes me, because those guys, they had no idea what they were doing. I mean, they had some idea what they were doing, but they were totally trailblazing doing that.
Yeah.
Hugo Burnham notes, I believe there were about 50 daughters of Nereus and Doris in Greek mythology, the sea nymphs, so plenty of scope for Neptune's newly discovered moon. And awesome. I guess if we do send that ice mission, that ice probe mission there, how did we describe it last night? Probing Uranus? Well, probing Neptune. That's
just a cheap one for.
I know. They would probably find a lot.
We had that conversation last week, Fraser.
Yeah. I can't help myself. I gotta keep bringing it up. Okay, well, you know what? I want to see Jason and Matthew fight, possibly to the death. So what we're going to talk about is a very controversial story about gold from colliding stars that Jason worked on. So what I want to do is, Jason, why don't you just present the story, and we'll watch Matthew just rage about the sort of the science, and then we'll let him respond.
I'll mute my microphone, and you'll just see my mouth flapping over here.
Just see the grumbling sounds. All right. Well, I'll frame it this way. Researchers from the Harvard-Smithsonian Center for Astrophysics in Cambridge were observing or looking further into a gamma ray burst. It was a short-term gamma ray burst located nearly 4 billion light years away, and it was just basically like a quick flash that left a glow. And when they did some research into the source of this glow around it, it was kind of an anomalous glow. They find that the cause of this gamma ray burst was likely two neutron stars that may have been part of a binary pair and smashed together. Now, of course, neutron stars are the remnants of sun-like stars, a little bit bigger than the sun, maybe from like, I think the numbers is 1.4 to 9 solar masses, so slightly larger than our sun. They've
8 times, eight times more massive.
It's 8. Okay.
Yeah, it's a lot bigger.
So you've got all this mass of the sun smashed down into basically the remnant core. So I mean, I think they like to say things like a teaspoonful weighs a billion quadrillion tons, so something ridiculous like that. Anyway, these two things smash together. And they produce heavy elements. That's what the glow is supposedly come from. It's a radioactive glow that was seen in the near infrared by Hubble. And part of that stuff that's left over is heavy elements, and part of those heavy elements are supposedly gold. So to add up how many of these types of explosions or collisions or whatever have happened throughout the history of the universe, they say, all right, well, all of gold on Earth probably must have come from these types of collisions. So then they kind of make that next jump, and they say, all right, when you look at your gold jewelry, you're looking at the pieces of or atoms that were created in colliding neutron stars. So, and they even gave a number, I believe, during a press conference at the CFA, saying about 10 times the mass of the moon from this collision was gold. So that's an awful lot of gold if you really think about it. Of course, that's scattered across the across the galaxy or across the universe. So little bits and pieces, and that's what eventually comes and lands on a planet, sinks into the core. Some ends up on the crust, and you end up getting things like gold teeth and gold jewelry and gold stuff inside of all of your components. So, but this is the part that makes Matthew angry because.
All right. First of all, I want to correct what I said earlier. You were right, Jason. You were saying the mass of the neutron star, and I was saying the mass of the progenitor star. So, okay. Yeah, I realized as soon as I said it that I said the wrong thing. But here's the thing: if you looked at what they said in the press conference and looked at what they actually said in the paper, there's no mention of gold in the paper or of particular elements produced. And when that happens, that says to me that they figured they probably couldn't get that bit past peer reviewers for publication. That's the kind of thing that triggers the whole. Okay, the reason they didn't put it in the paper is because they're not sure, and they don't have actually strong enough evidence for it. And here's the problem: is what you're seeing is this red glow at the same location as the gamma ray burst. It's probably associated with the same event. I see no reason to doubt that. It's probably what's called a kilonova, which is a hypothetical thing. Nobody's ever seen one before, but it'd be pretty cool if it was.
And that's an awesome name.
It is. I kind of roll my eyes out a little bit, but
stop. It's awesome.
Okay, kilonova. All right, we will grant kilonova as awesome for the sake of this conversation. But the thing that is you have to follow a chain of reasoning. You have to say, okay, first of all, this red glow is consistent with being a kilonova. If it's a kilonova, then what's making it glow is nuclear fusion, or nuclear reactions, not necessarily fusion the way we usually think of. Neutrons rapidly colliding with atoms and making heavier atoms. And if that's the case, then you could be producing elements like gold. Okay, and then you got to do a calculation to show, and I don't know how they did this calculation to show how much gold would be produced. And so basically, because none of that was in the actual paper, I don't know how they did the calculation. You don't know how they did that calculation. And so that's why I got a little grumpy about the press conference was all gold, 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 because the paper itself was very interesting. And I'd like to really, I think it would be wonderful if we could verify if this is a kilonova, if we could verify that others of these neutron star collisions do this kind of thing. Because if some heavy elements, including gold, come from this kind of collision, gamma ray bursts like this are really bright. They're some of the brightest things in the universe. We can see them at cosmological distances.
Well, considering that
that's
this
incredible.
was visible from 4 billion light years away.
And that's a close one.
And they refer to it as a close one.
Yeah, that's a close gamma ray burst. I mean, we talk about ones that are like 10 billion light years away. That was, I think that was one of the most, I can't remember now which of the most distant one was, but there was one that was briefly visible with the unaided eye.
But I guess the question is, does this mean that all gold comes from neutron star collisions?
That was my question.
Or does it mean, like what about
some could?
We have been taught that it's supernovae, right?
Yeah.
Right.
Yeah. That's what Carl Sagan always taught us.
Yeah. Was Carl Sagan wrong?
I would
Not
have to change.
necessarily.
I would have to change my entire star party spiel that I always tell people when I say my wedding ring came from a supernova.
But that's exactly it, right? Is if kilonovas are responsible for some, for gold, they may not be responsible for all the gold atoms.
And how would you get, I mean, aren't neutron stars incredibly dense? The gravity field, it's going to hold on to that gold. So how would you get from kilonova to, Earth to seeding, the solar nebula?
And that's actually another good point.
Thank you.
Supernova, yes, Fraser, you put your finger right on it. Supernovas, core collapse supernovas, the kind that we think of as being, we're star stuff. Get Carl Sagan to say billion for you, but those are located where stars are dense. That's where stars are young. They're forming. When supernovas go, they trigger more star formation. Where these short duration gamma ray bursts are located is where old stars are. They're out in the middle of nowhere, galaxy-wise. They're out in the outskirts. That's not where new stars are formed. So even if gold is produced in these explosions, we've still got to get a long way. We still have a couple missing steps to get that gold from that location into a new star forming region.
And then the idea is, do they like a core collapse supernova? Do they scatter these elements, out like they would have to, or are they like right, or are they like are they like the Tolkien dragons of the universe and they hoard their gold?
Ooh, I like that.
Nice.
I like that.
Oh, he just brought you down with a appropriate, story that just fed into your
left
Tolkien love. Devastating attack, Jason. I gotta say. All right, let's move on.
We're agreeing.
We are agreeing.
We didn't fight
You
as
know what?
much as you wanted us to.
I think, okay, so here's the takeaway from this, which is that when you see a ridiculous claim by a press officer in a press release and a news conference, you know that the scientists themselves are gritting their teeth during that press conference because of the ridiculous things that they're being asked to say.
The claims were said by the lead authors. So
even so, I know what's happening ahead of time. The press officer is saying, okay, so I've looked through your paper, I've tried to understand what you're telling me, and you're saying gold comes from, okay, that's it, that's what we're running with, we're going with gold, let's just focus on the gold and not about the kilonova, even though that would be an awesome name, or any of that stuff. So I think that's, a lot of that stuff. Whose phone's ringing now? Mine. A lot of that stuff comes from, that you try to make the news spread as far as possible. You want the big headline, and and you're going to dig and you're going to sort of twist it and tweak it and stretch it as best you can to get that to have the widest play. Yeah. And and we as the space journalists are the recipients of that and need to come at it with our skepticism and say, okay, you're telling us this, but that's a pretty big claim. What do you have to back it up? And I think, you can often tell the people who do this for a living because that's like your first line of defense. I don't know about you folks, but whenever I see that stuff, I'm like, okay, wait, what? And then I'll dig into it and try to put that in perspective. But a lot of times you see some of the more mainstream news and they just run it, they just reprint it, they just whatever just got said. If it came from NASA, then it's good enough for me.
If Hubble could find a solid gold moon around Neptune, that would rule.
There we go.
Then we'd get funding for that Neptune mission.
Yes. There we go.
We're going to bring that gold moon home. Come on.
Press release right now.
Well,
there's PR school.
There's way more gold in all of those asteroids out there already than platinum and iridium and all that kinds of stuff. And as we now know, it all came from colliding neutron stars. All right, let's move on. So you guys on the East Coast are having a horrible heat wave, and there's a really great. It's damn hot.
It's hot.
And there is a great picture that you posted. I'm going to try and dig it up while you talk about it, Jason. So what's going on here?
Well, I mean, starting. It's been, it's summertime. Yes, we know that. But this past week has just been a real sticky, humid, muggy, wet, hot mess over here on the eastern side of the U.S. And even up into Canada. The heat indexes, as people like to talk about what it actually feels like, it has gone up into the 105, 110 today. And so it's just been a mess. There's in fact I just looked at it last night. There's just a huge swath of heat advisories running from Minnesota all the way over to New Jersey, eastern Pennsylvania, Boston, Rhode Island, where I am. It's just it's just a mess. So one of the NASA satellites, I believe it was the GOES East satellites, actually captured what is you can see this heat wave from space. Now, what does a heat wave look like from space? In this particular image, it looks like a big old empty spot sitting right over the Ohio River Valley. And pretty much all of Ohio is a big clear area. So it made it pretty obvious. And I guess what that is a, let's see, there's a term there. It's a upper level ridge. And it was over the Ohio Valley on Monday, and a closed upper level low that was over on the western side of Texas and heading towards New Mexico. So it kind of trapped all this air in there, brought in a lot of moisture, and just sat there and got gross and sticky, and is pretty much what we're sitting under now. Now it's supposed to break, not to get into too much of a weather report, but it's supposed to break tomorrow when a colder front moves in. But up to then, it's just been kind of a unpleasant mess over here. So
you're not gesturing enough. You need to be like, moving in from.
You need the blue screen. There you go.
Where are you all located? Right, like I'm on the West Coast, in Canada, and it's been. Normally this is our kind of awful time of the year. August gets a little worse, but so far it's been great. It's been it's been nice, but not awful.
That system that's running across the western part of the country is actually giving lower than average temperatures down in the southwest and keeping it pretty comfortable up in the northwest. So it's the eastern half that's been sitting underneath all this gross stuff. I'm in Providence in Rhode Island, so I mean it's just kind of a gross situation over here. It's just that summer, but it's what was interesting was that was captured in a satellite image from space, so to see what a heat wave looks like.
And Amy, you are from Canada, and then moved to Arizona, and now you're on the East Coast. And how do you, now that you've experienced 3 different kinds of weather?
Nothing, like, it's not 119 degrees, so I'm fine. Like, it's just not nearly as bad as Arizona, and my body is still so tuned to Arizona. Apparently, I didn't know this till I moved there, that, like, your blood actually changes to properly cool yourself when you're dealing with 120-degree temperatures for most of the year, so I get freezing really easily right now, but this heat is not really bothering me that much.
Really? That's awesome.
Yeah, it's
no,
weird.
I spent 8 years in Dallas, and typically, when I was there, most of the summers were just, it was month after month of over 100-degree temperatures. Is it really humid? Not so much, but it's still really hot. So when they say, oh, it's not the humidity, or it's not the heat, it's the humidity, you know what? The humidity really does, make a difference. You come East Coast, and it's sweltering.
Yeah, Arizona's summer when it's that hot is way better than Toronto summer when it's like that hot and you have pollution and it's just sticky and it's like you get out of the subway and there's just a wall of air. At least in Arizona there's just hot air. It's air.
Like a pizza oven.
I can't even imagine.
It's like a hair dryer on you all the time.
Oh.
That's what Arizona feels like.
Okay, so we're gonna move on, and we're just gonna show a really cool picture of Comet Ison from Hubble. And now we actually showed this last week, but
yeah, Ison's on the other side of the sun.
Yeah, what's the update on Ison, David? So
Ison's on the other side of the sun, and I think the news cycle will pick up in late August when it comes back around and we get some more looks at it. And it's the big question mark is going to be how it brightens up when it heads in toward perihelion at the end of November, and what it does from that point from late August until late November. It's going to be the really big question mark.
And as we've been saying every week, it is either going to be the most spectacular comet in modern human history, or and you can't see my crazy hand gestures, or a complete non-show.
It'll be another Kohoutek from the 1970s. Yeah. So you got those.
Or it'll be somewhere in between. Somewhere in between.
If there's an option that it could be a good binocular telescope comet, like Pan-STARRS was earlier this year, but not the greatest visually either. So I think it's going to probably be the best after perihelion if it survives. It will be like Lovejoy a couple of years ago, where it'll unfurl this nice tail that you'll see in the morning sky.
So, but I mean, with Hubble observations, have we got any updates? Any idea? We really won't know until it goes past
Hubble's
the sun.
orbiting Earth, so unfortunately, Hubble's got that same blind spot that it's looking at right now too. So Hubble can't really get a look at it. I don't know if any of the stereo satellites might pick it up. I know that we were mentioning earlier about SOHO. Sandy was saying SOHO is going to observe it. It's going to pass through the LASCO C3 camera in November, so we'll be able to see a track through SOHO. But that's all.
So when will we know to freak out, change our plans, schedule, telescope time?
I think talking to comet expert John Bortle, I wrote a post on Universe Today a few weeks ago. I kind of concur where he was saying that I think it's going to underperform as it comes in. Then we're going to get this news cycle that Ison is a dud, Ison is a dud. Then if it survives that perihelion passage, then it might pick up where we're actually seeing something and we have a bright naked eye comet that we're seeing on the other side.
And so give me a date.
I would say right the weeks before Christmas would probably be the best time if it makes it through perihelion. It could be like Ellen a few years ago, where it was supposed to be the comet of the century, and there were all these conspiracies that Ellen was going to hit the Earth and everything, and it just broke apart and did nothing. So.
We broke it apart with our space lasers.
Yeah, I was waiting for that theory to go around that we launched Bruce Willis out there and he took out the comet somehow, and NASA did a secret mission out there but we tried to spread these rumors, but it just didn't seem to happen. So.
Yeah, we deal with this every single time. Okay, let's move on. So I've got one last story, and this comes from David. And you're talking about water trapped on red dwarfs.
Yeah, these are terrestrial planets around red dwarfs. There's the potential out there. It was a paper that went through astrophysics journals from Professor Kristen Minot at Columbia University. And they ran some studies using a program called Planet Simulator out of the University of Hamburg. And they were looking at terrestrial planets that were tidally locked, kind of like our moon, that are keeping one hemisphere toward their parent star, and they found that if about a quarter or more of the equivalent of Earth's water with the same insulation on those kind of planets in the habitable region, the habitable zone around a red dwarf star was present, that there would be a circulation pattern where it would actually form and pool as ice on the far side of the planet that never saw the red dwarf sun. And as that ice migrated around the front, there would be kind of a hydrological cycle where it would evaporate, circulate back, but you would actually have a little niche there inside the ice, the snow line of that solar system, where perhaps on the back of those terrestrial planets there would actually be ice and water kind of pooling back there. So it's another interesting place. There were some commenters on the post that mentioned something. It's like, yeah, I guess that's possible. They said, well, if it kind of tilted like the moon, where we actually get a little bit of libration where the moon is actually rocking back and forth, there might be a small habitable region where there's liquid water in between that transition region where there's ice on one side and then it's a parched, scorched planet on the other side, perpetually facing toward its red dwarf star.
Can I ask a question? This is, how far away are these? Because there's some concern about the winds from the stars sweeping away the atmosphere.
That's one problem that he cited in the paper, as far as, because the habitable zone is in, like, I believe it's like about 1/10 of an AU where it starts. And one problem life would have, of course, is red dwarf stars are very tempestuous as far as the amount of radiation and the storms they release there. That would be a big problem for life. And he did mention when I interviewed him that he said if the atmosphere was pretty appreciable, you probably wouldn't get that kind of hydrological cycle there too. So
that's well within the orbit of Mercury.
Yeah. I think that's where it begins. I'd have to look it up, but the red dwarf habitable zone is much closer, but it's broader than ours too. It's about like 1/10 of an AU out to, I think, like an 1/8 of an AU, something like that. I'd have to look at it again, but it's a lot wider than the habitable zone in our solar system is.
Okay, well, I think we're run out of all the stories that I had put up, unless somebody has anything else to talk about. I have one thing that I'd like to talk about, which is the Perseid meteor shower is going to be happening, as always, about 3 weeks from now, August 11th. And I have put an event on Google+, which is Go Enjoy the Perseid Meteor Shower. And so if you go search on event, search for Perseid Meteor Shower on Google+, you should find this event. Just click yes on the event, and then you will get a reminder in your email, in your calendar, when it's time to go outside and enjoy the Perseid Meteor Shower. That is the beginning and the end of what this event will be. And you know, it's going to be a nice moon this year.
Yes, I gotta say.
No moon.
Yeah. Favorable year.
So it's going to be a really great year for the Perseids, and it's summertime for the Northern Hemisphere, and you know, you get like 60 meters an hour, and it's just terrific. And so what I really recommend that you do is I put a link to the Dark Sky Finder, and you can go to your area, and it's great because it shows you this map of all of the dark sky in your area, and try and find a place that's yellow or darker, and go there and, like, you know, plan it out and, like, organize a bunch of friends and all go together and take some hammocks and some chairs and, like, lay back, binoculars, bug spray, depending on where you live. It's, you know, we don't have a lot of bugs here, so we're pretty good. And make a time of it, and, you know, prepare for the kids to conk out. But, you know, the longer you can hold out, the better it gets. You know, 1 in the morning, 2 in the morning, when it's really dark, it's just terrific. So you know, if you need something to do this summer, plan your whole summer around enjoying the Perseid meteor shower with your friends. Now, we're going to have all kinds of material. I'm sure David is already gearing up his brain on the stuff he's going to write about it. But and we'll get more information as you go. But just, you know, commit. I'm just saying right now, commit to enjoying the Perseid meteor shower. So, and all the folks here in the Hangout, are you all going to see the meteor shower this year?
Yeah.
Oh yeah, I'll be watching.
Amy?
I'll watch every year.
Possibly.
Depends. I'll be in Toronto, which is, you know, not the best place to look at the sky from.
They'll have the meteors there too.
Yes.
You can even see it from the city. Just go to a park. All right.
Near park.
All right. Cool. Okay. And so now let's. So for everyone, where can we find out more about the things that you do? Amy, share title.
You can find me in all sorts of fun space history. My blog, Vintage Space. I also write for Discovery News. I do videos for Scientific American, Al Jazeera English, Device, and Motherboard. And I will just throw out there that tomorrow is the 44th anniversary of Apollo 11, so come find me, and I'll be putting up tons of weird pictures of astronauts for fun.
And you've got an Upgoer 5 model behind you there.
I do, yeah. I can kind of. There you go. There's it's a 2-foot tall Saturn V.
Cool.
It's not lovely, but I built it myself.
I know.
Yeah.
At some point, you should bring one new model each time and hold it up and show us what you built.
Well, you can't see the ones on the shelf behind me, but I have my little lunar module.
Now, have you seen that Emily Lakdawalla knits them? I
think so. Now that you're mentioning that, I think I remember seeing knit landers.
That might be the next level.
Yeah.
Okay, David Dickinson.
Let's see, this week I've been active on my own site, Astro Guys, Listosaur, Canada.com, Universe Today, of course. I've got a post coming out this weekend. Another anniversary is the Great Meteor Procession of 1860. I got a little history post going up on that. And
is that the one that went across Canada?
It did. It went across northeastern U.S. and Canada, but there was a bunch of researchers that sleuthed it out a few years ago. There's a big article in Sky and Telescope. I wrote about it around that time too.
Yeah, I talked to the guy, one of the sleuths, and he was talking about it. And they actually saw that procession around the world, they thought. So,
oh, interesting.
Yeah, and so the thought is that maybe it was something orbital, like a moon, maybe a moon, something. So there's some really interesting story. Yeah,
I didn't know that facet of it. No, it might have been like the one we had last year over UK. They thought that skipped through the atmosphere and then came back again. Yeah.
Yeah, I will give you the name of the person afterwards. But yeah, it's a really.
I think it's the
story.
same one. Sounds like the same one.
Probably the same guy. Yeah. He's the one who also debunked the star positions for the Titanic.
Yeah, I think it's Don Olson. It might have been.
Yeah.
That's the guy.
Yeah. Okay. So, and if we want to read the other stories that you do.
And I also have a science fiction poem. I sold another one coming out to Starline magazine I think it's going to be in the October issue. Haven't sold any stories yet. Still working on that. So any publishers out there, I'm available.
You mean science fiction stories?
Science fiction stories.
Right,
that's one of my other hats I wear.
Right.
As a wannabe science fiction writer.
Jason Major.
I'm at lightsinthedark.com. I write at Universe Today, Discovery News Space, and you can find me on Twitter at JP Major. Oh, and if I can just plug a couple of books that I'm doing some reviews on right now. I'm working on. Hold on. This one right back here I got in, and I'm still going through it. It's from Time. It's called The New Frontiers of Space, and it looks like a coffee table book. It's got a bunch of really great pictures in it, but it actually goes in depth into a lot of the space exploration missions, past, present, and future. Really focusing on who's important in the space industry right now, what's coming up. So it was, I was really pleasantly surprised that it wasn't just a bunch of Hubble photos and Spitzer photos. So yeah, check that out, New Frontiers of Space. And
does anyone remember the Time Life Our Universe book?
Oh, those were great.
Yeah,
I grew up on that one.
I did too. I dog-eared. I destroyed that book. It is, there couldn't have been a more core influence on my life than that book.
Well, I see a book this big, okay, and I'm thinking, all right, it's going to have all the the Ring Nebula and all this other stuff that I've seen before. And really, what this new Time book is about space exploration and where we're going. So there's a lot of really interesting stuff that's pertinent for the future in this. And I also just finished Dave Goldberg's book, The Universe in the Rearview Mirror. I wrote up a review on this on lightsinthedark.com. This was a great time. I'm not a physicist. I know nothing about physics. I barely passed math. So his descriptions of how particle physics works and what symmetries are and all of this other stuff, I could pretty much understand it. I like to say at the end, my head is still spinning, but at least now I know it spins to the left. So
that's awesome.
He did a great job with that one. Anyway, check that out.
Have you read that, Matthew?
I have not.
I did. Well, it just came out 2 weeks ago. So
one thing, if you guys didn't realize, as science journalists, all you have to do is ask any publisher for a copy of any book whatsoever, and they will send it to you. In fact, it becomes a terrible burden as the books pile up and you never get to them.
I have a pile around my feet here.
I know. In fact,
I've got a few. Yeah.
I gave up, and now for Universe Today, like we just spread the books far and wide to a large team of reviewers because. Like for me, I'm a kid in a candy store. If you send me all the stuff. I will totally never get around to it and never get around to writing a review.
Well, if I leave myself to my own devices, I won't read any books. I'll only read articles online and tweets and other stuff like that. So actually having people send me a book to read about something I'm interested in is, by giving me an assignment, I'll actually do it versus, I'll just wander through a bookstore and go, oh, this might be interesting someday.
Yeah.
As if there were any bookstores that existed anymore. They're kind of like, dinosaurs now.
And I'll just tell all of you watching as well is that if you want to review books, let us know because we are always looking for more reviewers and we have lots of books and we get them sent right to you.
I'll review books for you.
Great. Just drop me an email. But yeah, so we're always looking for more reviewers. And the deal is you get to keep the book, but you got to write a review. And that is the arrangement. Right. Okay. And Dr. Matthew Francis, where do we find out more?
bowlerhatscience.org, galileospendulum.org. Lots of stuff there. You can find me at arstechnica.com, BBC Future. That seems to be the most popular places these days. Nautilus, the new Science and Culture magazine, and wanted to put in a plug for the next round of Cosmo Academy classes. So cosmoquest.org/classes. You will find classes from various people, including Pamela Gay and Emily Lakdawala, who many of you know from Planetary Society work and also Space Hangout. But big things coming, so please sign up for our classes and learn about all sorts of cool stuff.
Yeah, just to we are giving people the opportunity to spend weeks on end with some of their favorite people in space and astronomy and learn directly from them for a very low price compared to what you might do to go and get your PhD. I mean, come on, Matthew, your PhD must have cost a fortune, and now we're giving the equivalent of it, in 8 short weeks. So.
It's actually not even 8 weeks. We're talking 2 weeks to. You will get your hands on Mars rover images, and you will turn those into pretty pictures. So this is the kind of class we're offering you.
That's terrific. Yeah, and I am amazed that people aren't just filling these up in a heartbeat. So we need to push this a little harder. So
we get PhDs, so you don't have to.
You don't have
there
to.
We go. There we
exactly.
Go.
Cool. Well, thanks everyone for watching. Thanks everyone for joining us this week. It was great. And next up is, I guess, going to be the virtual star party on Sunday night, where we hook up a bunch of telescopes into a live Google Plus Hangout and show you whatever's up there. So thanks everyone for joining, and we will see you next time.
And don't forget to wave at Saturn.
Wave at Saturn in 1 hour.
Over an hour.
Yep.
20 minutes, yeah.
Okay.
It'll be out in the rain.
Cassini's watching.
Bye, everybody. Hi, Saturn.
-N1 right now. It's probably going to be named for a sea nymph before long because all of Neptune's moons are named for some kind of sea goddess or sea nymph because the Astronomical Society or the IAU has to do everything has to have a theme. But it's kind of a neat discovery, not just because it's a new moon, but because I think it's kind of a neat reminder that we don't actually know very much about that we don't actually know very much about Neptune. I mean, we only found Neptune in 1846. And then its main moon, Triton, was found within 17 days, I think. Sorry. And then the moons came pretty slowly thereafter. I forget when the second moon was discovered.
I think it was Nurid, back in the 1940s. I can't remember the exact year.
You want to tuck your phone out that door and put it in that closet behind you?
Airplane
it's my mom. She keeps calling back when I hang up on her. I think you're right. Yeah, it was in the mid 40s that someone found it, and then it wasn't until Voyager 2 got to Neptune in 1989 that we discovered 6 more moons, and all of a sudden the system was huge, and Neptune has all this crazy weather going on in its clouds, and it has
and the
rings.
ring arcs too. You know?
Yeah, that people thought that, or astronomers rather, thought that it was sort of half ring arcs, and it turns out that they're very fine rings, but they're complete rings. And then in 2005 we found 5 more moons and more Hubble data. So this keeps coming. And I think it's kind of interesting that we don't think about how little we know about Neptune, but there's a lot to know about Neptune, and Triton itself is pretty awesome.
Well, a lot of this stuff comes in waves, right? You get the situation where you've got, like, I know with the with the New Horizons, right? It's going to be showing up at Pluto, and you're going to have a new instrument that's really close, and it's going to be able to. I'm sure if we've already found, what are we up to? 5, 12, however many moons.
5 for Pluto.
Yeah, there's going to be more probably when you get that instrument. You get this stuff in waves. We discovered a bunch with. So hi everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, July 19th, 2013. Today we're going to talk about balloonatics, a new moon for Neptune, the fact that an astronaut almost drowned, recreating the pale blue dot, gold from stars. Terrible heat wave, new images of Comet Ison, and water trapped on red dwarfs. Joining me this week, a ragtag crew of space journalists. We've got Sonny Springman at the Arecibo Observatory. We've got Amy Shira Teitel from Vintage Space.
Hello.
We've got David Dickinson, a.k.a. the Astro Guys. We got Jason Major.
How's it going?
And last but not least, we've got Dr. Matthew Francis.
Greetings.
All right, so let's get cracking first. Now, Sandy can only stick around for about another 20 minutes, so we're going to start with the story that she wanted to talk about, which is balloonatics. And I will be honest, I had no idea what she was talking about, and spent the first 5 minutes or so just trying to digest this new information. So, Sandy, please explain it to me again, and now use small words.
Only small words.
Yes.
Well, I'm a small person, so that's okay. So we're going to be, later in this hangout, you all are going to be talking about Comet Ison, which is going to be making a nice pass through the inner solar system later this year on Thanksgiving, actually. It's going to make its closest pass to Earth. And we're going to be pointing every spacecraft we possibly can lay our hands on at it. Messenger is going to be looking at it. Hubble's been taking beautiful images of it. And there's a bunch of other, I think even SOHO, anything that can point at the sun is going to be looking at this thing. But also there's some risk. As this thing comes in through the inner solar system, it might break apart if there's a coronal mass ejection, if there's a large solar storm, this thing could lose its tail. It could become a total dud for reasons we don't even understand. So a number of scientists at the Applied Physics Lab at Johns Hopkins University are actually designing
with Voyager. So this is going to be. I think we talked about this last week. We need another ice giant mission.
We do.
Yes.
I would love to see something that goes, and I don't know anything about orbital trajectories, but something should go from Uranus to Neptune and study the moons on the way, because, yeah, that'd be awesome.
When I was a kid, Neptune only had 2 known moons.
Yeah, exactly. I was actually thinking about posting on Twitter, like, how many moons do you think Neptune has? Because I think in my mind it's 5. I'm trying to remember, like, when I learned how many moons it had.
When I was in grade school, it was 2.
It was 2, yeah.
So not till Voyager 2 went by in the late 80s did it start, the numbers.
When I was a kid, Pluto was a planet.
I know.
Thank you.
That kind of dates me.
That's
Isn't
awesome.
that true for all of us, though?
Yeah. Okay, so let's move on, and let's talk about this actually quite scary spacewalk that just happened this week.
Yeah, there was a routine spacewalk Tuesday morning. This was the second of 2 routine spacewalks. So they had done one the week before. This was Luca Parmitano and Chris Cassidy. Luca Parmitano is an ESA astronaut, and Chris Cassidy is a NASA astronaut. And I'm watching these spacewalks kind of over on one monitor while I'm writing, and I'm kind of intermittently like turning it on and muting it as they're doing it. And then in the first hour or so when I turned it on, I noticed they were starting, Luca Parmitano was starting to have reports of water in his helmet. And they cut that spacewalk short. It was supposed to be a 6 to 7 hour spacewalk. They finished a few initial tasks, but ended up only being an hour and 32 minutes. They got him back inside, and it was a little tense there. It wasn't as bad as it sounded once they got him back in, but there was points where they couldn't actually communicate with him. They were telling him over the comm that it's like, if you can hear what I'm saying, squeeze my hand. And he wasn't actually communicating out of the helmet. And he said later it was kind of like being, like a goldfish trapped in a bowl.
To point, that's crazy. And then what happens when the balloon pops?
Well, it doesn't pop so much as they let it back down, and then they chop off the payload, and they expect to recover it, but it might be a few days. So you have to design for that. So
because
then,
if you ever see those people who launch those weather balloons, and they always, they go up really high altitude, and then I know, like with those weather balloons, they just get bigger and bigger and bigger until they pop.
Yeah, The goal is not to get this thing to pop, because that would be bad. I mean, you can sort of design your payload for litho braking, as they say, litho like the lithosphere, and braking like aero braking, except you expect it to crash. So you don't really want things to crash. There's a video going around right now on YouTube of them putting this thing together, and it looks kind of delicate. I just wouldn't want that to crash into the ground. So this is kind of bold and audacious, and I hope they're successful, and I hope they get some really sweet images of this thing and get some great science.
Now, we got a request from YouTube. Somebody wants you to show us the dish.
I can't show you the dish from here.
Oh,
you
well,
might be able to see the telescope. There, you can see the telescope.
Oh, yeah. There we go.
Coming out of the woods.
It's become almost tradition.
And Hugo Burnham says, I didn't know you sailed, Fraser Cain, but actually I think it's your icon.
It's my icon with the sailboat.
Yeah, I actually do have a sailboat, though, so I do actually sail.
Can I come visit you?
Anytime.
Yes.
Okay, what is next? So let's talk about the new moon for Neptune. Amish, your title?
Yeah, Neptune has a new moon. Well, not really, because it's had that moon for a while, technically, probably. But it's new to us, so that's kind of neat. So it was Mark Showalter at the SETI Institute who was looking at pictures of Neptune taken by Hubble between 2004 and 2009, and he found a little dot. So he tracked this dot in 150 images and was able to actually figure out that it's a moon, figure out that it's orbit, and confirm that it's a moon. So now we have this moon that I think is called something like S2000.
A balloon to carry a suite of instruments up into the upper atmosphere, not quite this space, for 22 hours. And they're only going to get 10 hours of science out of this. But this is kind of nuts. So I'm calling them balloonatics for that reason, and I really hope this term sticks.
Well, there's a lot of really interesting balloon science. Have you seen the Blast documentary?
I love the Blast documentary. And one of my friends is actually working on Blast Pole, which is the successor. It's really neat.
If anyone hasn't seen it, it's not only is it sort of great if you love space, but it's actually like one of the best done documentaries I think I've ever seen.
It's a balloon and Antarctica.
Yeah, hard times 12. But there's a lot of science that gets done with balloons like this. The high altitude weather balloons. So this isn't.
And the reason we do this at high altitude is because we have all this water in our atmosphere, and that's really great. But it blocks a lot of very interesting stuff that you would see in the ultraviolet. And we also have this really nice ozone layer, so the more you can get above our atmosphere, you can see stuff that our atmosphere would otherwise block. So that's why we try to have telescopes in space. We have telescopes on planes, and we also have telescopes on balloons. So this telescope's only going to be about 30 inches across. It's not even going to be a meter, but they're going to get a lot of stuff out of it. And they're not just going to look at this comet, but they're also going to look at a couple of asteroids and other objects that have interesting UV characteristics. So it's kind of nuts that it's only going to be less than a year from the time that they decided that this comet was actually discovered in 2012, I think, and when they've decided they're going to launch this thing in the fall. So that's bold, as Gentry Lee would say.
Bold.
Bold. So yeah, this is going to enable us to get some really sweet photos of Comet Ison, aside from the new ones.
What I've always wondered, being a backyard astronomer, it's tough enough to point my own telescope. How do they point a telescope on a balloon?
That's I think they were probably using star trackers. I think they're probably using a lot of the technology that they would use on spacecraft. That's just my guess.
But to reorient the balloon when it's up there to keep it pointed in the right general direction, then have the telescope itself actually be able to